Hey, welcome back, class. Just picking up with this week's new worksheet. This one deals with the remainder theorem and also tying in synthetic division and how you can evaluate polynomial functions using synthetic division rather than just plugging in an input. Then we get into like factorability quickly. And eventually, towards the end of this worksheet, we'll do a little solving polynomial functions for their roots algebraically. But for today, it'll just be factorable ones. Later in the week, we'll get into unfactorable ones and how you use some of these methods for that as well. So the big thing to recap is to go over the idea of synthetic division, something you probably saw last year, but it's a simple process, actually. It's just adding two numbers and multiplying two numbers. It's really it. But we'll go through the step-by-step instructions for it. We start out with this worksheet with this concept of the remainder theorem. So just to go over that, what basically that means is if you take any function, f of x, and you divide it by a factor, so in this case, we're dividing it by x minus a factor, this is going to yield another polynomial function 1 degree less, because if you take, let's say, an x cubed function and you divide by an x, you're left with an x squared function. So this function that remains, we'll call it g of x. It's always going to be 1 degree less than the original polynomial you're dealing with. And many times there's some remainder that you get. And we always put remainders if we're dividing by a linear binomial, that's a first degree binomial. That means the remainder is just going to be some constant. The remainder always has to be 1 degree less than whatever it is you divide by. If you divide by an x squared factor, you can have a x to the first factor left over. If you divide by a first degree factor, you can only have a constant left over. So this is that constant. And the way we write remainders a lot of times is that constant over the factor that you divided by. So this would be your total answer to the quotient if you were to divide some polynomial by any linear binomial. So that's very in the weeds kind of math jargon right there. But what we're going to look to do is see this right here. We're going to try to find that remainder right here. This thing right here is called the remainder. And again, if you're dividing by a linear binomial, that's a first degree factor, your remainder is always just going to be some constant. Okay, so we're going to look to see how synthetic division can get us that value pretty quickly. So in the beginning here, we've got a second degree polynomial divided by a first degree. That means we should get an answer that's some first degree factor. Now, to find out if it goes in evenly and if there's a remainder, we can use this concept of synthetic division. So to set that up in the beginning, we use synthetic division involving the coefficients only. That's why it's kind of an easy process. You don't have any algebra really to deal with synthetic division. It's just the coefficients. So if I set up my board, I have a 3 coefficient, a negative 13 coefficient, and a negative 10 coefficient. And then the linear binomial that we're going to divide by is x plus 5. So in here is the root from the factor that we're dividing by. So if x plus 5 is a factor, we saw last week that means that negative 5 must be one of the roots of that factor. So we're using the x value from the factor, not the actual sign of the number in the factor. In other words, it's always going to change signs when you go from a factor to the actual input. Okay, so now the actual process is pretty straightforward. Okay, what we do going straight down right here is we add straight down. Right? Columns are always going to add. So we add 3 plus nothing, we just get a 3 down at the bottom. Okay. And then what we're going to do diagonally is multiply this diagonally. So this is going to be a multiply diagonally. So when we multiply 3 times negative 5, you get negative 15. And then again, we're just going to add straight down. Negative 13 and negative 15 is negative 28. Okay. And then if we do multiply diagonally, I won't draw the green arrow just so it doesn't get too confusing. It's negative 28 times negative 5. And so that is going to be a positive 140. So I'll write that one in green. That's positive 140. And so what we're left off with is this last box. This last column is like the remainder column. I usually set it off with a separate little space right here. Negative 10 plus 140. And when we add those together, we get a positive 130. So the remainder comes out to be 130. And this is the